Warning, lasers can blind you instantly, and CO2 lasers are invisible. Take caution and wear proper protection around any laser. This is incredibly dangerous and is only shown for educational purposes. Hi, welcome back to Projects with Everyday Dave. I'm here with my son Jordan because today we're going to show you our DIY 50-watt CO2 laser that we've been building over the last couple of years. I've enjoyed doing projects with my kids ever since they were really little. We used to go to Home Depot on Saturday mornings and put together the little projects, and they've gotten more and more complicated over the years. From things like modifying a scooter to run on LiPo batteries to bigger and bigger projects like this CO2 laser. So today we're going to show you an overview of how we put it together and what's in it and some projects that we've started to make with it. So take it away, Jordan.
Let's start by taking a look in the electronics bay of the laser. In here, we have the power supply. This allows us to take in the wall voltage and convert it down to various other voltages that feed into the rest of the systems. Probably the most important of these is the high voltage lines, which run up to the tube itself. These allow an arc to form between the front and back electrodes, and that's what actually creates the laser. Now, following the 5-volt line, we get to the Arduino. This is the brains of the whole operation. It connects via USB to a computer, which allows us to actually control the various functions of the laser, and it's mounted onto the laser through this perf board that I have soldered it onto. Actually, underneath this chip, you can't see it right now, but there is a TTL chip, a NOT gate, because the Arduino itself is a high active fire signal for the laser, and the power supply expects a low active signal. So it's kind of a pain to set up and work around this perf board, which is why I am glad that the sponsor of the video for today is PCBWay. PCBWay does PCB manufacturing as well as CNC and 3D printing services, and they're running a $5 deal right now where you can get multiple PCBs. Moving forwards, we plan on partnering with PCBWay to build a maximum power point tracker, which will allow us to evaluate the performance of various different panels, whether they be new or used, and use that power to charge up batteries, which we can use for later projects.
If you'd like to use one of PCBWay's services for one of your projects, check out the link in the description for $5 off of your first purchase. And now, let's get back to the laser.
It also connects over here to the 24-volt motor controller. Now, if we were to run the motors directly off of the Arduino, they would draw enough power to fry it, which would not be good because then we wouldn't have a working laser anymore. So this stepper motor controller allows us to use the small 5-volt signal from the Arduino to control the 24-volt stepper motors. This gives us much more power moving the gantry around and protects the Arduino from damage. Moving over here, we have a DC to DC converter, which steps that 24-volt line down to a 12-volt line, which we can use for this solenoid. We'll get back to why that's important in a moment. So, continuing to follow this wiring up into here, we have the back end of our control panel. Now, this allows us to see the current running through the laser tube, so we can make sure we're not running at too high of a power. It also gives us external control of various systems of the laser, so that way we can turn things like the air assist, water cooling, and venting fan on and off from the outside without having to open this panel up. So coming back to the solenoid, this tubing goes down below to this air compressor, which flows through this dryer and regulator up into the solenoid. The solenoid connects to the front panel so we can turn the air assist on or off. And what that air assist does is it allows us to blow air out the nozzle of the laser, so that way smoke and debris don't get up and damage our lens. While we're down here, we also have this 5-gallon bucket, which contains water, which is circulated by this pump, up into the rest of the laser. Now, we found that if you don't add algae control drops, that you can get some nasty stuff growing in there, so that's definitely a must for this kind of a system. So these tubes come up into the laser, where the water enters in the back, exits from the front, and flows around this outer sleeve of the tube. That allows us to keep the entire laser cool, so as the water exits, it comes out through this flow gauge. This is a simple binary on-off gauge. It tells us whether or not the water is flowing. And actually, this information is not shown anywhere on the laser, but it's tied directly into the safety circuit. So if the water is not flowing, the laser cannot fire. This is important because an overheating laser can cause the glass to shatter, sending glass everywhere, and expose it to high voltage leads. So let's go ahead and move around to the front of the laser, where we can see this nice door design that we made. So you can begin by opening this front hatch, which is a really simple way to get into the laser if you just want to do small things or if you just want to reach in and grab the thing you just cut. It's a nice easy way to get simple access to the laser. But this isn't a whole lot of room to actually get into the laser. So because of that, we designed it as a double hinge. So this whole front door opens, allowing complete access to the entire cutting area of the laser from above and in front. And this has been really helpful for being able to get large sheets in. We have this acrylic sheet on top, which allows people to look into the laser while it's cutting. Now, we made sure to get a black tinted piece, so that way the bright light that's produced by the cutting itself is muted as it comes out. Of course, anyone who's looking in there should be wearing laser safety glasses, but this is just an extra layer of protection. On the front of the panel here, we have the main control panel for the laser. This shows us the current flowing through the laser, as well as giving us control over various systems inside of the laser. So this allows us to make sure that the laser is firing. If there's no current flowing through the laser, then obviously there's no laser coming out of the tube, which is important because the laser is invisible, so we need to know whether or not it's firing. It's another safety feature we have on the laser. Speaking of safety features, this top switch is the laser enable. The laser cannot fire if the switch is off. And this switch over here is the door close switch. When the door is closed, it presses this button on the limit switch, which tells the system that the door is closed and that it's safe to fire the laser. This switch, and this switch inside of the water loop are the main components of the safety circuit which prevent the laser from firing if it would be dangerous to do so. The other switches on this panel control things such as the water flow, the air assist, and the air evacuation systems. With the door open, we can move into the main area of the laser and kind of get a better overview of what's going on in here. The main systems that are going on in here are the movement system, the laser positioning system, and the air exhaust. Starting with movement, we have the Y-axis gantry, which can move forwards and backwards, controlled by the motor that you saw back in the electronics housing. There's a belt on the front and back to move it to prevent the axis from being skewed as it moves, and just provides equal pressure for moving this around. The x-axis is moved with this belt. We chose this direction to be the x-axis. Typically, on a laser, the x-axis moves parallel to the axis that you would face the laser, but we chose to do it this way for faster rastering. The z-axis is currently not powered, although we do have future plans to make it powered. This table here is moved with these screws in the four corners. Currently it's done by hand, but in the future we are planning on adding a motor to make that a little bit easier for us. With the movement out of the way, we can move on to the actual path of the beam itself. The beam starts with the arc that forms inside of this laser tube, which generates the laser from the CO2 inside of the tube. That laser comes out, hits this first primary mirror, which then allows it to come down here to the secondary mirror, reflects it down the x-axis to the tertiary mirror, which sends it down through the lens into the workpiece. While we're over here, we can see this tube, which provides the air assist from the compressor, and that prevents any smoke and debris from going up into the lens by blowing a constant stream of air out of it. The cutting area of this laser is 2 foot by 4 foot. Well, technically 2 foot 2 inch by 4 foot 1 inch, but for all intents and purposes, 2 foot by 4 foot. That leads to a very large cavity inside of this, which can fill up with smoke very easily as we're cutting materials. The vent fan, which can be open and closed with this shutter, takes care of that. Now, because of the high volume of this laser box, we needed a fan that can move a lot of air in a very short amount of time. So the solution that we went with was a bounce house inflation fan. So if you come around to the side here, you can actually see this 3D printed collar, which allows us to interface with both the laser and the fan. And this fan's been working great. It's been doing a good job of blowing all of the internal air out through this tube and out of the side of the building. And that allows us to keep the laser box clean and free of smoke, and so we don't lose any laser power as the laser is traveling to the cutting material. For construction materials, we use aluminum extrusion for the rails, as it's an easy way to get something that's light and very straight to get these rails running true. For the exterior, we did use wood because we were trying to do this as cheaply and quickly as possible to get a good prototype running. The laser is currently functional, which is great, but in the future we do plan on exchanging this wood exterior for something metal because wood can be a bit of a fire hazard. So we make sure that we are always monitoring the laser while it's running, and we have been taking other precautions to make sure that we don't set the exterior on fire.
I have to say, this is probably the funnest project that we've gotten to do together, and it's come a long way from the PVC pipe and 3D printed
contraption that you first made for a CNC.
Yeah, this one works a lot better than that one did, and it's a lot more useful too. The other one could only carry a pen, so it's kind of nice having a laser cutter.
Yeah, we can make some actual parts now, and I'm really looking forward to what we're going to be able to make with this. And the first project you did was pretty cool.
Yeah, that lamp turned out pretty well. Didn't think it was going to look quite as nice as it did. I think that the final product was a lot better than what I was originally planning on making. But yeah, it fit together really well, and the machine worked perfectly.
Yeah, I thought that was pretty awesome. Well, we've got a lot more projects planned. Solar-related projects, battery-powered scooters, battery backup systems, and now that you're doing electrical engineering, I'm really counting on you to improve the quality of products that we're able to execute.
Well, we'll see where that goes.
It's going to be awesome, I know. Thanks to PCBWay for sponsoring this video, and if you want to see more videos like this one with projects that we've been doing together, let us know in the comments below, and we'll see you next time.